This video is on section 5.1 notes, angles, and their measurements. So first, we're going to be talking about the measurement of degrees. And within degrees and within radians too, when we talk about radians in a little bit, there's some different vocabulary terms that are going to be important for you to know and to be comfortable with. Not that I'll ask you to define them, but I'll just be using those terms. And as I use them, you should understand and be able to mentally picture what I'm talking about. So standard position is kind of the default position that we use for angles, and it's an angle whose initial side is on the positive x-axis. So here's the initial side, or kind of like the start of the angle, and this is exactly what an angle looks like when it's in standard position. And you'll see angles marked like this, kind of in this circular from 0 to 360 over here. The 360 is not labeled, but a full circle would be at 360 degrees. So we have the initial side over here, and then the terminal side is kind of the ending side, and you measure the angle between the two sides. Knowing the difference between these two is not as big of a deal, but it's good to know in case you see formal math vocabulary. A quadrantal angle is an angle whose terminal side is on an axis. So it could be like a 90-degree angle is a quadrantal angle, 180 degrees is a quadrantal angle, 270 degrees is quadrantal, 360, because the terminal side ends on one of the axes. A coterminal angle is an angle in standard position that has the same terminal side. So it could be 45 degrees, and then if you were to draw an angle where you went around the whole circle and then kept going, that would be 360 degrees plus another 45 degrees, which would be 405 degrees. And we'll talk a little bit more about that later on in the notes. Positive angles are angles that are measured in the counterclockwise direction, so starting at 0 at the positive x-axis and then going counterclockwise. And then negative angles are angles that are measured clockwise from the initial side, so starting at 0 they would measure going down, going clockwise. All right, so to start with, we're just going to draw some angles, and you can kind of use this as a reference to help you. So it says draw each of the following angles in standard position, and then asks which quadrant the angle is located. And typically when we ask where an angle is located, we're not asking where is the entire angle located, we're asking where that terminal side ends up. And we're asking which quadrant. So we have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So a 106-degree angle is going to be between 90 and 120. So if we have 90 and 120, then 106 is going to be closer to 90 than 120, maybe approximately, and try to draw a straight line, approximately right in here. And so I would say that this angle right here is about 106 degrees. And the terminal side lies in quadrant 2. 238 degrees is going to be very close to 240 degrees, just a little bit off of 240, which is right down here. So this is a 238-degree angle, and the terminal side lies in quadrant 3. And you'll notice most people label their quadrants in Roman numerals. But if you did 2 and 3 and did your, I think they're called Arabic numerals, if you write an actual 2 or an actual 3, somebody can correct me on that if I'm wrong. That's fine too, but Roman numerals are a little bit more common in this context. All right, 312 degrees. So if we look back here, 312 is going to be really close to this one right here, 315. So just a little bit less. There's our 312-degree angle in quadrant 4. And last, we have a 58-degree angle, and we have this 60-degree angle right here. And so a 58-degree angle would be slightly less than that. And that's in quadrant 1. All right, next it says to find 2 positive and 2 negative angles that are coterminal with -50. So coterminal angles are angles that are in the same position, but are 360 degrees apart from that angle that you're talking about. So if we're talking about an angle that is -50 degrees, that means that it has been measured backwards. It's been measured by going clockwise instead of counterclockwise, and so it went down 50 degrees. And so if it went down 50 degrees, we would take 360 and subtract 50 degrees, and it would be down here somewhere, which is going to be coterminal with an angle that's between 300 and 315 degrees. And the way that we calculate coterminal angles is we take the angle that we are working with, in this case we'll be working with -50, and we add k multiples of 360. So positive multiples, we add 360, or negative multiples, we subtract 360 to get those other measurements. So I'm going to say -50 degrees plus 360 will get me my first positive coterminal angle. 310 is the first one, and then to get my second positive coterminal angle, I'll add another 360 degrees. So I get 310, and then 310 plus 360 is 670 degrees. And then to get my negative coterminal angles, I will just subtract 360. So -410 and -770 degrees. Next, it asks us to determine if 2 angles are coterminal. So are they in the same spot or are they not in the same spot? Does the terminal side of the angle lie in the same location? And so to determine that, we just have to figure out if these 2 angles are 360 degrees apart. I can start with 190 and subtract 360 and see if that gets me to -170. Or I could start with -170 and add 360 and see if that gets me to 190. Either way, it does. And so I have confirmed that they are coterminal. So this is a yes, they are coterminal. And if I look at my notes, I can kind of see this. If I were to measure positive 190, I would go counterclockwise and go just past the 180 to 190. If I were to measure -170, I would go backwards and go just under 180. So you can see how those would be in the same location. All right, next we're going to talk about radian measurements. It's just another way of measuring angles. So we have first something that we'll work with a lot in this course is called a unit circle. And basically a unit circle is a circle with a radius of 1. Typically when we talk about the unit circle, we talk about something more specific than that. If you've had anything related to trigonometry in a math class before, then you have been introduced to this before, which is typically what we think of when we think of a unit circle, but technically a unit circle is just a circle that has a radius of 1. A radian is the angle that is made at the center of the circle by an arc whose length is equal to the radius of the circle. So if we have this unit circle over here, I know that it's a unit circle because I can see the ones are labeled. This is a radius of 1, this is a radius of 1, a radius of 1. So if this radius measurement of 1 is kind of copied over here and they make this a length of 1 as well, so that this arc is a length of 1, then this is the definition of 1 radian. And 1 radian is approximately 57.3 degrees. And we'll talk more about how to convert between degrees and radians in a second. So that's how radians are defined. I will not test you on that. I don't care if you can define a radian. I mostly care if you can work with them. So we know that 1 radian is 57.3 degrees. We know that 1 degree is 0.01745 radians. Again, I don't care so much that you have these memorized. When we get to the next page of notes, I'll talk more about what I care about you being able to do. Just like in degrees, we have coterminal angles with radians, and we'll talk about how to find those in a second, but you use a different formula. Instead of using the angle plus 360 times k, you're going to use 2 pi times k, and we'll talk about why in a minute. All right, so on the next page, it has the comparison over here between degrees and radians. So you can see each of the degree measures and their corresponding radian measurement. And you'll notice that it's very important here. All the degree measurements that we have little degree bubbles on them, and that's important because radian measurements don't have anything. So if you have a number that you write down and it does not have a bubble, the automatic assumption is that you wrote it in radians. So if you write degrees, you have to have that little bubble there. Now, the conversion that is important for you to know is that 180 degrees is pi radians. 180 degrees is pi radians. That means that 360 degrees is 2 pi radians. And that's why the little formula for coterminal angles for radians is the angle plus 2 pi k instead of being the angle plus 360 k, because now we're talking about a full circle being 2 pi instead of a full circle being 360 degrees. All right, so here's our conversion. They're asking us for these first 2 examples to take an angle measurement that is in degrees and to convert it into radians. So what we're going to do is we're going to multiply this by a fraction. And the fraction that I'm going to multiply is going to be equivalent to 1. It's not going to look like 1, but it's going to be equivalent to 1. And it's going to change the way that my angle measurement looks. But my angle measurement is still going to represent the same size of angle. Okay, so a 200 degree angle, I'm going to convert this into radians. I want to get rid of my degrees, and so I'm going to put 180 degrees down here because my little degree symbol is going to cancel out. And then on the top, I'm going to write the units that I want to convert it into, and this is the pi radians. So if you remember maybe from chemistry or from an earlier math class, when you would convert your measurements, you would kind of write down 2 equivalent measurements. So we have pi radians and 180 degrees. The degrees are going to cancel out and we're going to get a number in radians. So in my calculator, I'm going to type 200 divided by 180. I'm not typing in the pi because if you noticed up here, all these numbers typically have a pi written in them when they are written in radians. So I've got this decimal. I'm going to hit the math button on my calculator to turn this into a fraction. 10/9. So this is the fraction 10/9. The pi that I didn't type into my calculator, I'm going to write up here. So 10 pi ninths, if I want my answer in radians in exact form, 10 pi ninths. Or I could type into my calculator 10 pi ninths, and that would be 3.491 radians. All right, and again, I don't have to write anything because when you put nothing after this, we assume automatically radians. But if you want to write RAD for radians, that's fine. Okay, next we have 23.6 degrees. I'm going to convert that into radians. So I'm going to put 180 degrees on the bottom so that the little bubble will cancel. I'm going to stick the pi on the top. 23.6 divided by 180. I'm going to turn this into a fraction. 59/450ths. The pi that I did not type into the calculator is going to jump to the top of the fraction. And if I wanted to write the approximate measurement for the radians, then I could just type this in. 59 pi divided by 450. This would be 0.412 radians. So these are equivalent. They are just the exact form of the radian measurement or the approximate form of the radian measurement. All right, so here it says to take the radian measurement and convert it into degrees. And so here, since I want to convert this into degrees, I want to introduce a degree bubble into the problem. So I'm going to put 180 degrees on the top to introduce that bubble. The pi goes on the bottom because I want the pi's to cancel out. So the pi's will cancel out. I'm canceling out the radians, and I'm just going to do 7/5 multiplied by 180. 7 divided by 5 multiplied by 180. 252 degrees. This one is the type of problem that often confuses students. They see 12.3 and they automatically jump back to a problem like this and they think it's talking about degrees, but it's not. It says 12.3 and it doesn't have a little bubble. So that means that this problem is in radians. It is not in degrees. So we have to take this and we have to put a pi on the bottom and say that to cancel the radians out, we have to divide by pi. Now, the reason you don't see a pi over here is just because they have done what we did up here, and that is include the pi in the problem. I'm sorry if you can hear the bells jingling. My cat just walked in the room, and he has bells on his collar. So we have a pi on the bottom. We're going to put 180 degrees on the top so we can convert this into degrees. And then here, since we can't actually cancel out the pi like we did on this other problem, we're actually going to type it into the calculator this time. So we're going to do 12.3 times 180 divided by pi. And that is 704.738. All right, next it says find 2 positive and 2 negative angles that are coterminal with pi sixth. So if we want 2 positive and 2 negative angles, that just means we have to add a full circle twice and subtract a full circle twice. And so I'm going to take pi 6 and I'm going to be adding and subtracting 2 pi times k. This is a formula that could give us all of the angles that are coterminal with pi 6. And if you were to do this without a calculator, then you would have to think about how could I add 2 whole numbers to a fraction 1/6. Because I've got a pi in there, but if I try to type the pi into my calculator, I'm just going to get a nasty decimal. So if I have 1/6 and I'm adding 2 whole pi's to it, then I can think of this as 1/6 plus 12/6, or 1/6 minus 12/6. So to get my first positive coterminal angle, I'll say 1 plus 12 is 13 pi over 6. And then I can take 13/6 and add 12 again, and I'll get 25 pi over 6. So there's my 2 positive angles. To get my negative angles, I'll just subtract 12. So negative 11 pi over 6. And subtract 12 again, and I get negative 23 pi over 6. And of course, if you don't want to have to do the fractions by hand, you can always do them in your calculator. So if I type in 1 divided by 6 like this, and hit the math button and turn it into a fraction, then if I add 2, it'll keep those as fractions for me. And I can subtract 2, negative 11/6, negative 23/6. So the key here is just to remember not to type in the pi. If you do that, your calculator has to leave it as a decimal. All right, so the next thing that we're going to talk about is arc length. And the arc length is just a portion of a circumference. So a circumference is the entire perimeter of a circle. And we know that the formula for circumference is 2 pi r. Circumference is 2 pi r. So if we want to talk about the arc length of a circle, then we want to talk about just a portion or just a percentage of that entire circumference. So if I wanted to just look at, this is an A or an alpha, it looks like a Greek letter. If we just want to talk about alpha degrees or alpha radians out of an entire circle, then to calculate our arc length, which they use an S to denote arc length, then we would say the arc length is alpha radians out of 2 pi radians multiplied by the circumference. So this is the portion of the circle divided by the whole circle. Times the circumference is going to give us just a portion. It's going to give us the arc length. Alternatively, you might have seen something like alpha out of 360 times 2 pi r if you were using this formula in terms of degrees. But we're not. Typically, when we work in this class and when you work in higher level math classes, starting with pre-calculus, moving into calculus, and so on, they tend to ditch degree measures and work exclusively in radians. So you'll find that the more we do with trigonometry, the less we see degrees. So here, when we have alpha over 2 pi and the multiply by 2 pi from the circumference formula, these 2 pi's cancel out. And we just get that the arc length is the angle measurement that we're talking about, alpha, multiplied by the radius. And so it ends up being a pretty simple formula to use. So this example says we have a wagon wheel that's shown below with a diameter of 28 inches and an angle of 30 degrees between the spokes. What is the length of the arc between the two adjacent spokes? So if the diameter is 28 inches, then that means the radius is 14 inches. That's important. And then we have that the degree measure between the two spokes is 30 degrees, but our formula is in terms of radians. So I'm going to want to convert this into radians. So I'm going to divide by 180 degrees so that I can cancel out my degree measurement. And I'm going to put a pi on the top so I can introduce my radian measurement. So 30 divided by 180 is 1/6. So this is 1/6 with a pi on top, 1 pi over 6, or you could just say pi over 6. And now we're going to say that the arc length is the angle measurement pi 6 multiplied by the multiplied by the radius. And I can multiply those together. Here, if I were to write the 14 as a fraction, it would be 14 over 1. So I have that the arc length is 14 pi over 6, or 7 pi over 3. And that's inches because the radius was in inches. So 7 pi thirds inches. If somebody told me that the length of something was 7 pi thirds inches, I would punch them in the face. And so I'm going to type that in and see what the decimal is. This is approximately 7.330 inches. You can put whatever measurement my math lab asks you to put there. My math lab will not punch you in the face. All right. For 4 years, U-2 spy planes flew reconnaissance over the Soviet Union, collecting information for the United States. The U-2, designed to fly at 70,000 feet, well out of range of Soviet guns, carried 12,000 feet of film and a camera that could photograph a path 2,000 miles long and about 600 miles wide. Find the central angle to the nearest tenth of a degree that intercepts an arc of 600 miles on the surface of the Earth. And it says the surface of the Earth has a radius of 3,950 miles. So they're asking us to find this angle measurement. They gave us the arc length. They gave us the radius. So S equals angle times radius. We have the arc length is 600. We don't know the angle. We know the radius is 3,950 miles. So they made this problem interesting by telling you a little bit of history, but a lot of the numbers were just unnecessary here. So I'm going to solve for alpha and divide these numbers. And I get that decimal right there. And this number is in radians, and so they asked us to find this central angle to the nearest tenth of a degree. So I want to convert this from radians into degrees. And how do I know that this is in radians? And I know because my formula is in radians. So we didn't use this formula. We used the formula where the 2 pi's canceled and we had an angle measurement times a radius. If we were doing degrees, then our formula would have a 2 pi in it. So that's how I knew that my answer was in radians and that I couldn't just use this as the degree measure. All right, so I need to take this and convert it into degrees. So 0.152 times, if I'm converting it into degrees, then I need the degree to be introduced. So I'm introducing the degree bubble. I'm going to divide by radians to cancel out the radians. And then since there is no pi to cancel out on top and bottom, I'm actually going to type it into my calculator. So I've got this decimal. I'm going to multiply by 180 and divide by pi. And you'll notice that even though I rounded this decimal to write it on my paper, I'm not going to plug in the rounded version when I calculate this because then my answer will be a little bit wrong. So I'm using that exact answer when I do my calculation here. So alpha is 8.7 degrees. Rounded to the nearest tenth is 1 decimal place. So 8.7 degrees.